Hi everyone, my name is Pavitra V, Department of Chemistry. Today we are going to discuss a topic called atomic structure. You can see the images which can explain you the structure of an atom, how it will be. It is the center part, nucleus, which consists of a proton and neutron, and electron is revolving around the nucleus. This is the atomic structure. Basically, we will discuss what is an atom is. Every matter consists of basic entities called elements. Each element is composed of a smallest particle called atom. Atom is the name is derived from a Greek language atomos, which means not to be cut, because when we cut an atom, we will get enormous or huge amount of energy, so that in the earlier studies we are not able to accommodate or we are not able to afford that huge amount of energy. But nowadays it is possible to cut an atom into small, like fission reaction, from which we are getting a nuclear power plant. From that we are getting a electricity. So nowadays it is possible to get a cut in atom or a fission of an nucleus. So this is the atomic structure, in which it consists of a positively charged nucleus at the center and negatively charged electron which is revolving around it. The radius of an atom is about 10 power minus 10 meters, and the radius of the nucleus is around 10 power minus 15 meter. Nucleus consists of a proton and neutrons which are together called nucleons. Most of the mass of the atom is concentrated at the center, that is in the nucleus. Next we will move to the representation of an atom. See, A, X, Z is the representation of atom, where A is the mass number, X is the element symbol or the element, and Z is the atomic number. This is the representation of an atom. Here, for example, uranium-235-92, where X is the uranium, that is the element, and A is the mass number, that is 235, and Z is the atomic number, that is 92. Now we will discuss what is the atomic number and mass number by taking an example, helium 24, where mass number is 2 and atomic number is 4. Atomic number is nothing but number of protons in an atom. Mass number is nothing but it is the total number of protons and neutrons present in an atom. Always number of electrons is equal to number of protons. So atomic number is also given as it is the total number of electrons present in the atom. But for an accurate purpose, we will count the number of protons for atomic number. Next we will move to the theories of atomic models, in which Neil David Bohr, a Danish physicist who developed Bohr model for atomic structure, in which he introduced the theory of electrons orbiting around the nucleus. He is one of the scientists who explained about orbit. Next, the Bohr's theory postulates or the assumptions of Bohr's theory are a fixed circular orbit in which the electrons are moving around the nucleus in a concentric circular orbits. While revolving in stable orbits, the electrons do not radiate energy in spite of their acceleration towards the center of the orbit. Which means unless and until an electron is subjected to an external field or an external energy, it will not change its path. Each of the fixed orbit is associated with a definite amount of energy that is called as stationary energy. The energy levels are numbered as 1, 2, 3, 4 or designated as K shell, L shell, and N shell, so on. Jumping of an electron from one energy level to other, that is ground state to excited state, is also available. Principle of quantization of angular quantum of moving electron. An electron can move only in that orbit in which the angular momentum of the electron around the nucleus is an integral multiple of h by 2 pi. So the moving of or the momentum is given in terms of integral multiple of h by 2 pi. Next, this is the model given by the Bohr, in which, see, this is the nucleus centered and electron is revolving around it with a definite path called orbit, and these are the energy levels. Limitations of Bohr's postulate, that is, there is no explanation for spectra of multi-electron system. Bohr's give the explanation of one electron system, that is hydrogen atom, but he fails to explain multi-electron system, and there is no explanation of fine spectrum of the atoms. Also, he fails to explain about Zeeman and Stark effect. Zeeman effect is nothing but when a magnetic field is applied on an atom, it's usually observed spectral lines split. This is called Zeeman effect, in which the spectral lines also get splitted in the presence of external electric field. This is known as Stark effect. There is a dual behavior of matter, that means that material particle at atomic scale in some circumstances behaves as a particle and in some circumstances behaves as a wave. This means some phenomena related to the particle can only be explained if we forget its particle nature and regard it as a wave. So, it have both particle nature and also a wave nature. In order to explain a matter and a wave nature, we can give an explanation like this. Matter is one which is having a mass, momentum, and at the same time and the same place, two objects cannot coexist. But in the wave nature, we have wavelength and frequency. But here two waves can coexist together at same time and same place. This is the wave nature. Wavelength is nothing but it is the distance between two consecutive troughs or two consecutive crests in an wave. And the frequency is, if we are marking a point, the number of wavelengths or the number of waves passing through that point per second is measured as a frequency. Its unit is per second or hertz. The unit of measurement of wavelength is in terms of meter. This is the differentiation of a matter and a wave. For this dual nature, we have a mathematical expression. For particle nature, we have E1 is equal to mc square. M is the mass of the particle and c is velocity of light, that is 3 into 10 power 8 meter per second. And for wave nature, we have E2 is equal to h mu. H is Planck's constant and mu is frequency. Also, E2 is equal to hc by lambda. H is Planck's constant, c is velocity of light, and lambda is the wavelength. We have expression in terms of frequency and also in terms of wavelength. When we equate these two energies for a dual nature, E1 is equal to E2, that is mc square for particle and hc by lambda as wave energy. We have an equation for wavelength as lambda is equal to h by mc by rearranging the above equation. Mc, that is mass into velocity, is given as momentum, or when we consider a particle, in place of c we can write it as v. Here v represents the velocity, that is momentum is equal to mass into velocity. Lambda is equal to h by mv. This is the equation. This is also called de Broglie's equation. This is very much important. De Broglie's equation, lambda is equal to h by mv, where lambda is the wavelength which is measured in terms of meters, v is the velocity of the particle, that is meters per second, m is the mass in kilograms, h is Planck's constant in joules per hertz. Next, we will move to the Heisenberg's uncertainty principle. Here, the uncertainty principle states that the position and momentum cannot both be measured exactly at the same time. That is, If you are measuring the momentum, you will not get an exact value of position. If you are measuring the position, you are not get an exact value of momentum. That is given in a mathematical expression as delta x into delta p is more than or equal to h. That is, delta x is the uncertainty in the position, delta p is the uncertainty in the momentum. That should be greater than or equal to h by 4 pi or h by 2 pi or h. This is for numerical purpose and this is for application purpose. The more accurately you know the position, that is the smaller delta x, is the less accurately you know the momentum, that is larger delta p, and also vice versa, where h is a Planck's constant equal to 6.6 into 10 power minus 34 joule second or joule per hertz. As h is so small, these uncertainties are not observable in normal everyday situations. Okay, then we will move to the hydrogen atomic spectra. We have a series, 5 series of spectra for hydrogen atom: Lyman, Balmer, Paschen, Brackett and Pfund. We will observe Lyman series in ultraviolet radiation, Balmer series in the visible region, in which we will get a Vibgayar spectrum, and in Paschen series is seen in near infrared, Brackett is seen in far infrared, and Pfund series will be seen in far infrared itself. In the infrared region, we have 3 regions like near infrared, middle infrared and far infrared. Near infrared is near to the ultraviolet and visible regions. These are the wavelengths given, and in Lyman series, all the spectral lines will meet at n is equal to 1. That is energy level n is equal to 1. We will get the spectral line meeting in n is equal to 2 as a Balmer series, and so on. This is the explanation of hydrogen atomic spectra. Next, we will calculate a Rydberg constant for Balmer series. This is for Balmer series, where 1 by lambda is equal to r into 1 by 2 square, that is n1. In the Balmer series, all the spectral lines will meet at n is equal to 2 value. So we are taking n1 as 2. 2 square minus 1 by n square. N square is from where actually a spectral line is drawn. This is the n series. See here we have E3 to E2, E4 to E2, E5 energy level to E2 energy level, E6 energy level to E2 energy level. So this is the formula to calculate where n is equal to 3, 4, 5. These are the energy levels and r is the Rydberg's constant. These transitions emit visible photons. So Balmer series lies in visible region. So we will get a visible photons emitted.